right? We said that if you have two equations and we were to put them into y equals mx plus b form, or like the slope-intercept form, if they have the exact same slopes, that means that they will be parallel, right? As you can see here, they're parallel, so they'll never intersect, right? If they never meet each other, no solutions. Um, this one, and you'll see again, it has different colors, right? Let's see like why that happens. So let's say that I have, and I'm going to put, I'll label this 1 and I'll label this 2. So I'm going to do the first one right here. Okay, that's 5x plus 2y equals 2. Now I'm going to put in slope intercept form because I know that that's easier to see and understand. So to do that, and you should really like pause and like just try to see if you can do it. I'm going to move negative 5x over, okay, and this 2y will come right down, okay. Now the equal sign, see that comes right afterwards, and then you combine this piece. Well, you can't do that because this doesn't have an x, so you need to keep it in y equals mx plus b form, which I'll write here again. This is y equals mx plus b, so our x is going to come first, so negative 5x, and then the plus 2. And to get the y here by itself, you gotta slice it, so like divide everything by 2, and what you're going to get is y equals negative 5 over 2x plus 1. Okay, I'm going to go ahead and I'm just going to just put a rectangle, box it on that. Then for the second one, that's this piece over here. Let's choose a different color. You have 2.5x plus y equals 1. Don't worry about the numbers. Do the same thing, right? Get into y equals. So subtract 2.5x, subtract 2.5x. All right, this comes straight down, equal sign, right? Cannot combine these. There's no x here, so we're gonna write this first, plus 1, and let me just change that color right there, right? Plus 1. So now if I put a box around this, you have to think, well, how do these compare? Okay, maybe I can actually move this. So let's see. Give me a minute. Let me see if I can like try to move this. All right. If I do this, can I move this? Yes, it looks like I can. Sweet. So I'm gonna go ahead and just label it like that. Now, as I'm doing that, look at each of the equations and see if you can determine what's the same. I'm just gonna write back this 1 here. Okay, so y equals, this doesn't really look like the same. Okay, x plus 1. Now, on your calculator, if you were to do 5 divided by 2, okay, that's the same thing as 5 divided by 2. This is the long way of doing it. You can totally just go on your calculator and just do it, okay? You'll see that 5 over 2 is exactly the same thing as 2.5. So this is really 2.5. And what you'll then see is y equals negative 2.5x plus 1 and y equals negative 2.5x plus 1. What does that mean? It means that they're exactly the same. Exactly the same lines. So wouldn't it make sense that if we were to graph both of these, they would be literally on top of each other, right? And they're not even really on top of each other. Like they are the same exact thing. And so when they're the same exact thing, it's like, okay, well, how many times are they intersecting it? Well, one. Like, look at all this. Every single spot. Every spot. So we say that that has infinite solutions. Infinite because this line doesn't stop there. It goes on forever. This line goes all the way down forever. This line goes all the way up forever. And so they touch each other at every single spot infinitely. So if you have the same slope, same y-intercept equals infinite solutions, same lines. All right, so that's what this idea is. All right, so I do want to do a word problem one. I'm gonna go ahead and just end the video here because I feel like this is gonna be a little bit more time consuming, and then we'll continue from that.